between the film and the substrate. And the other source is the intrinsic stress or the residual stress. This is a collection of some factors, one of which could be lattice mismatch between the substrate and the film, and the other is parameters like grain growth, grain boundary diffusion, and all these parameters happen at the same time. Thus, we term them as the as deposited stress. The film that we are talking about here is metallic films, and these films usually have a tendency to grow in a 3D growth mode. That is a Volmer-Weber growth. And by 3D growth mode, I mean that they don't have a tendency to grow epitaxially. They kind of have a signature stress thickness curve. By convention, positive is the tensile stress and negative is the compressive stress. What happens when initially the film deposits, the film nucleates on various sites on the substrate, and as the film thickens, we see that these nuclei grow in size into islands, and there is a difference in the internal and external pressure called as the Laplace pressure, and due to this pressure we have the bending of this substrate, and which corresponds to this compressive region initially. As the film thickens, what happens is these islands grow and touch each other. When they touch each other, due to the reduction in surface energy and surface area, these islands will coalesce and form a grain boundary, and due to this we get a tensile region, and we finally get a tensile peak when there is a complete coherent layer formed. And as the film grows in thickness, we see that the stress will depend on the kind of film that we are depositing at the post-coalescence period. If we are depositing low atom mobility films, that is like refractory metals or maybe iron, we will get a less tendency for the relaxation, and if we are depositing high atom mobility film like FCC metals like nickel, we will have a more of a tendency for the films to relax. One thing that we can see from here is the stress in the films can be measured by the change in the curvature, and Stoney developed an equation which relates the change